Hello. So, a lot of what we're going to be doing for today's lesson is we're going to be reviewing over some of these angles that we talked about and that we've talked about in the first unit, but maybe things that we haven't heard in a while that are going to come back into play in a big way. So, when we've been talking about our similar triangles, right? Similar polygons, we said that we were looking for angles that are congruent and sides that are proportional. So this is going to help us a little bit, especially when we start proving that that two triangles are going to be similar. We need to start by figuring out, are these angles all going to be congruent? And if we know that the angles are congruent, or if we can figure out certain things based on the picture, that's going to go a long way in helping us. So let's review some of these different type of angles that we have. So the first one we have is vertical angles. So vertical angles are two angles that are across from each other, across from each other on intersecting lines. So for instance, this one, like the 1 and the 2, those are vertical angles with each other. They're right across from each other. Same with 3 and 4. And if you notice, when we're talking about these vertical angles, they have to make a perfect X when they cross. So for instance, if I'm up here and I do something like that, there actually aren't really going to be any vertical angles because vertical angles are always congruent and no four of those angles are congruent to each other. So it has to be perfectly across. So that's the first one that's a reminder. Next, adjacent. This isn't going to help us as much. I just kind of want you to remember this word. It's just any two angles that are next to each other. So here's two angles here, angle 1 and angle 2. They're next to each other. They are adjacent. Another one, I'm going to go kind of around the block in a weird way, but complementary, we also won't see that all that much, but it's just two angles whose sum adds to 90. So for instance, this angle here might be a 60-degree angle, and this might be a 30-degree angle. Those would be complementary because the two of them add up to 90 degrees. Supplementary is going to be two angles that add up to 180. So they kind of connect with linear pair. They're a little bit different, but I always think of them together a little bit. It might look something like this, where this angle is 30 and this angle is 150. Those two would add up to 180. So they're going to be supplementary angles. And we'll talk about the difference between that and linear pair in just a second. But one way that I always like to remember it, the difference between complementary and supplementary, because people forget this sometimes. So we've got complementary. I'm going to put an S for supplementary. The way I remember it is I can add a line here and I get 90. So like they add up to 90 degrees. Over here for supplementary, I like to finish that and make that an 8. Looks like 180. So then that's going to be supplementary. So that's just a nice little tricky way that I like to remember the difference between those two. But the difference between a linear pair, though, so I actually down here, and I probably didn't do a good job, I drew these two together. So let me redraw it for a second. Even if these two angles, that was weird. Sorry about that. Even if these two angles aren't next to each other, right? If this angle down here is 30, and this angle over here is 150, do they still add up to 180? Well, yeah, they do. They're both sum to 180. So that'll be supplementary. So it doesn't necessarily have to be next to each other. It doesn't have to make a line. But if we have two angles that add to 180, they're supplementary. And that's the big difference when we start looking here at linear pair. So linear pair, they have to be next to each other and add to 180, which means every time they're going to form a straight line just like that. So angle 1 and angle 2, those could be a linear pair. Let's see, could be something like this. Maybe it's a little more even, this 3 and this 4. Again, as long as they're next to each other and add to 180, they're going to be a linear pair. So we might see some of these angle relationships, and there's a couple of, there's going to be a couple examples down here where we'll look at numbers, but first, just as a nice reminder, and it might even be a good opportunity for you to stop the video and to try on your own, but see how many of these you could label, or which one of these labels correctly describes the picture that you're seeing. So try to do this on your own, see if you can get them. The answer, it could be more than one thing, but give it a try, and I'll talk about them in a second. All right, so hopefully you had a chance to try them a little bit. Let's go through and see which one of these describes the picture. So our angle 1 and angle 2 in this problem right here, and problem number 1, are they adjacent? Well, adjacent means next to each other. They are not next to each other. Are they vertical? Well, let's see. Well, they have this perfect X here, and they're across from each other. So yes, they are going to be vertical. Are they complementary? Do they add up to 90? Well, I don't really know. I don't know anything about those angle measurements, so I can't say for sure. So I'm going to cross that out. Do they add up to 180? Well, again, we don't really know for sure. They could, but since we don't know, we can't say that. And then last but not least, are they a linear pair? Well, they don't make a line. And we were saying that linear pair means that they're both adjacent and supplementary. And since it's neither, it's going to be neither. So it's just vertical in this case. For problem number 2, let's take a look. Are these two angles adjacent? Are they next to each other? Well, yeah, they are. Are they vertical? Are they across from each other? No. And notice, it's never going to be adjacent and vertical, right? They're not opposites of each other, but they just can't exist at the same time. Complementary. Let's see, do they add to 90 degrees? In this case, kind of a weird way, even though we don't know the angle measurement, we can say yes. Since we know that this here, oh, sorry, I lost my mouse. Since this here is a 90-degree angle, and this forms one big straight line, we know that those two have to equal 90. And again, that one's not one that we're going to use as much, so if you were a little bit confused on that, that's okay. If they add up to 90, they can't also add up to 180. That would be illogical. And then, do they make a line? Well, notice all 3 of these make a line, but when we talk about linear pair, a pair is just 2. So if we're looking just at those 2 angles, no, they do not make a line. And then when we go a little bit further down, one of the nice things that we know is if we can recognize something special about these, we might be able to solve for or find out other angle measurements. So for instance, in problem number 1 down here, we have an angle that's 112 degrees, and we need to find angle X, let's call that. So if you notice, if we can recognize one of our 5 things from up above, it might be able to help us out. So in this case, these two are vertical angles. And one thing we always know is that vertical angles are congruent. And sometimes you see it marked with that line. That just means those angles are congruent. So this would mean that X is 112 degrees because they are the same, because they're vertical. For number 2, it's going to be a little bit different, but same idea. We're going to look to see, hey, which rule or which angle, I guess, is are we talking about? Or what can describe this angle? What kind of angle is it? And in this case, well, I see that 90-degree angle. That's a really, really, really good hint about what it's going to be. So in this case, it's complementary. These two are complementary angles. They're also adjacent, but that doesn't help us with the numbers per se. But we know that these two angles together, based on our definition, should add up to 90. And then from here, we can go ahead and use some of that algebra that we've done before, and we can solve to get that value. So in this case, X would be 22 degrees. And then last but not least, right, same thing in problem number 3. We're looking to see what do we know about those angles. Well, they're adjacent. That's 2 angles that's next to each other. We know that they are supplementary, so they add to 180. And since they're both of that, we actually know it's a linear pair. They make a line. But let's go back to the fact that they are supplementary. That means that 124, my bad, plus X. Oh no, what happened? Sorry, bear with me, I'm writing with my finger. Plus X equals 180. Oh man, is that gonna cut that off? All right, I'm going below. It's kind of messing up here and I don't wanna mess you up. So 124 plus x equals 180. Boom, there we go, we figured it out. All right, so just like we did before, we can subtract those two, and we should end up getting that x equals 56. Sorry, I kind of ran out of room there. But so that's kind of how we can use those, right? Depending on what we know about those angles, we might be able to find something out or be able to solve for something that'll help us in our problems. Let's look at some other words that might look familiar that we need to check again. And I'm actually going to eliminate, oh man, me and technology are just not agreeing today. If you haven't noticed that, if you haven't had me before in class, me and technology never really agree, so that's okay. All right, we're not going to really talk about alternate exterior angles, but we will talk about these other three. So when we're looking here, we have this picture on the left that's got two lines that's cut by another line, and we call that third line, this line T, we call that a transversal. That just means it cuts through two other lines. And if you notice, it kind of breaks it up into groups of four. That's how I like to think about it. So if I were redrawing it maybe a little bit bigger, I've got a group of 1, 2, 3, 4 over here. And I kind of like to think of it as my top left, my top right, my bottom left, my bottom right. And then I got the same thing down here. If I covered up that top one, I get the same thing. My 5 would be my top left, 6 would be top right, 7 would be bottom right, 8 would be bottom left. So when we're looking at corresponding angles, all right, we're looking at two angles that are in the exact same position and in both of those two groups. So for instance, if I were to ask which one were both the top left, well, that would be angle 1 and angle 5, because they're both in that top left position. Other corresponding angles would be my angle 2, top right, and my top right on the bottom, which would be angle 6. Same with bottom right, which would be angle 3 and angle 7. And then last but not least, we have angle 4 and angle 8 are both in that bottom left position. So that's what we mean by corresponding angles, is same spot, different group of 4. Now let's look at our alternate interior angles. So if you notice here, we've got kind of an inside-outside thing going. If you notice, these 4 here fall in between those two lines, right? In this case, they call them L and M, right? So if I'm looking back at my original picture, these all show up right here in the middle of them. And that's what we call the interior of it. Whereas the exterior, right, which we aren't going to deal with as much, but I want to remind you, is going to be the ones that I didn't highlight. So when we look at alternate interior angles, we want two angles that are on the inside, but that go with a different side of the transversal. So sometimes I like to think of it, and I'm going to put it in red, I like to think of it as like the left side and the right side. All right, so if I'm looking at alternate interior angles, well, let's start with angle 4. The alternate interior to angle 4, well, it needs to be on the right side, and it has to be in a different group of 4. And I'm going to pause there for just a second because that's important. If you were to say angle 4 and angle 3, if you notice, I wouldn't even need this group down here, right? There wouldn't be any interaction with it. I could just say that 4 and 3, they're next to each other, they make a line, they're a linear pair. So when we're looking to see, oh goodness, when we're looking to see which ones are going to be alternate interior angles, that means we're interacting with one from this group of 4 up top and one from this group of 4 down below. So this time it'll be angle 4 and angle 6. And then just like that on the other side, alternate interior angles will be angle 5 and angle 3. And then last but not least, consecutive interior angles. That just means they're both on the inside and they're on the same side of the transversal. So if we're looking at angle 4, in this case, same side of the transversal. And in that different group of 4, it's got to be angle 5. So we're looking for interior angles that go with angle 3, right? That's an interior angle. The consecutive interior angle would be angle 6. And I know I put that in the wrong spot. Draw an arrow up to it. But that's what we're looking at with consecutive interior angles. So those are just the name of it. And now to the point where we're going to start using it more in our class, which is if 2 parallel lines are cut by a transversal, all right, that means those 2 lines are parallel, they're got the same slope, they're moving the exact same way. Well, then we know even more about those different angle relationships, right? We know that those corresponding angles are going to be congruent. Our alternate interior angles are going to be congruent. I'm going to skip the exterior ones because, again, we're not going to use them as much right now. But we know that each pair of consecutive interior angles, or sometimes we call them same side interior angles, is supplementary. And if you notice, that's a nice vocab word that we just used up above. That's going to mean that those two add up to 180 degrees. And just like we talked about above, vertical angles are congruent and linear pairs are always going to be supplementary. So we kind of have some of that information, and let's see what that looks like. So I'm going to redraw this over here just because it's kind of hard to see. All right. So we've got, they say that angle 1 here is going to be 65 degrees. All right. We need to find out what angle 2, 3, 4, 5, 6, 7, 8 are. But I might not even look at that. What I'm going to look at instead is I'm going to look to see my relationship between them. So for instance, that one's 65. I just said that if I have corresponding angles, so remember, same spot, that top left, same group of 2, or same different group of 4. Let me restart that, sorry. So this one's in the top left in that group of 4. If it's corresponding, if I talk about this angle right down here, these two should be the same, which would mean that if this angle up here in the top left is 65, the angle down here should also be 65. If I'm looking, I said that alternate interior angles are going to be congruent as well. So here we go. I've got an interior angle right here. If I'm looking at the opposite, or excuse me, alternate interior angle, that's going to be right here. So just like that first one was 65, this one's also going to be 65. And if you notice, one last one, well, actually, let's go back for a second. If we have this one that's 65, and I say that this angle right down here, and I'm going to mark it with the 2 mark, just meaning that I'm just showing you that I'm talking about these two. Not that they're the same necessarily, but I'm talking about them, right? So if I look at the 2 greens, those are same side interior angles or consecutive interior angles. So I know that this angle with the 65 plus this angle down here, denoted with the 2 green lines, those should add up to equal 180. So I'm just going to do my work over here. 65 plus whatever that value is should be 180. Well, I can use my math. I can solve for that, right? If I go ahead and subtract that, I'm going to end up getting that. That angle is going to be 115 degrees. So we can use some of the knowledge that we know, especially about labeling these angles and knowing the relationship between them, to help us figure out some of these different angles. And again, hopefully this is starting to look a little bit familiar. It's going to remind you of what we did from last semester a little bit. And we'll talk more next class about how we can apply that specifically to triangles. But I'm also going to pan down here for a second. If I can, let's see if I can figure this out. Let's see if I can get this to work. No? Okay, that's fantastic. But we'll talk about it here in a second when I start over here. So you should be able to see my screen now, I'm hoping. It kind of talks a little bit more about the angles inside of a triangle. So let's use some of the information that we know. It says in the figure below, triangle TUV is drawn. Line WTX is drawn such that that line, which I don't like how they labeled that line because we should only use 2 letters, is parallel to UV, right? So now we have two parallel lines, and notice we're going to have them cut by a transversal. So I'm going to try annotating over the screen. We'll see how this works. We have this angle TUV, and we're saying that this is going to be congruent to something. Well, let me just look here for a second. If I have this line right here, and this parallel line right here, and we have this big line here cutting through them, well, once again, even though it's kind of tilted from what it looked like before, all we have is two parallel lines cut by a transversal. And if you notice, this angle right here, and I'm going to try to change the color real quick, this angle right here is an interior angle. So if we know that this is an interior angle, well, we can go to the opposite. So I'm going to go to the other side of the transversal, and I'm going to find the other interior angle. So that one right up there is going to be the same. So if I look at my answer choices, this angle WTU is going to be equal because, just like we said before, they're alternate interior angles. Now I'm going to erase it for just a second because it's going to show you this. See how that kind of flips around and fits perfectly there? That's why that works. That kind of shows an example of it. Same thing is going to be here. If we're still looking at these lines, right? We've got this line here. We've got this line here, right? I could also think of this as a transversal, all right? So if I know this one, oh, let me change the color. This one down here is an interior angle. Well, the opposite interior will go right there, which means that XTV is going to be congruent to UVT. So we'll go down here, we'll hit XTV or VTX because they are also alternate interior angles. And again, you're going to notice that slides up. So now we have two angles here that we know, and we have this third one here. Well, if you notice, even though we're talking about 3 as opposed to 2, I have 3 angles here that make a straight line. All these angles, if they make a straight line, we know what a straight line is, right? That's 180 degrees. So we know that they should add up to 180 because they're supplementary, or if they form a straight line. That works too. All right. And so we can go ahead and we can solve for that, right? We could say that 34 plus x plus 86 equals 180. So I would end up getting that x plus 120 equals 180. I could subtract 120, just kind of a little algebra review, get that x is 60. And if you notice, we could figure out the missing angle. So anytime, and I'm going to erase it and I'll move it around here in a second, but anytime that we have a triangle, if we know 2 angles in that triangle, we can solve for the third one because all 3 angles in a triangle should add up to 180 degrees. And it doesn't even matter what my triangle ends up looking like. You ready? Even as I adjust it, right, all those numbers are going to adjust as well. But we can go ahead and we can solve for that last one. So for instance, in this case, if I were to add them all up, right, 41 plus x plus 30, set it equal to 180, I'd know that x is going to end up being 109. So we can use some of the information that we talked about on this worksheet, thinking about some of these angles, and we can apply that to what we know about triangles. And that'll help us solve for some of those sides, or excuse me, some of those angles that we're missing. And once we know that the angles are congruent, then we can go ahead and we can start proving things about the similarity of those triangles. So hopefully this is a nice little review, and you're going to get some practice on at least some of these angle types and figuring those out in just a second. But remember, if you're looking through this and maybe you're like, wow, Mr. DiGiulio, that was really confusing. I'm not super sure I understand it. It's kind of hard for me. Reach out to us. We are always free. You have 3 math teachers. So if you weren't at the meeting the other day, we all introduced ourselves. We have 3 of us there teaching you guys. So it's me, Mr. Fife, Ms. Grabowski. We are here to help. Reach out to us, send us a message on Canvas, come stop by our office hours, and we'd be more than willing to help you out. So even if this is confusing, work with us because, again, we want to make sure that you do the best that you can in this class. So go ahead, give a try for the Delta Math, and if you have help, reach out.